for the Tes. Ladies and gentlemen, please pay attention because of the Visiting Professor 2025 program is about to start. We kindly seek your cooperation to make today's seminar run smoothly. Kindly switch your mobile phones to silent mode to avoid interruptions. Thank you for your cooperation and attention. Assalamualaikum warahmatullahi wabarakatuh. Salam, Om Swastiastu, Namo Buddhaya, Salam Kebajikan, and Salam Sejahtera to all of us. Welcome to the Honorable Professor Hidefumi Yoshii from Setsunan University, Japan, our distinguished guest lecturer. Dean of Vocational School, Universitas Diponegoro, Professor Budiono. Vice Dean of Vocational School, Dr. Ida Hayu Dwi Mawanti, and Dr. Engineer Vita Paramita. Head of Study Program, Dr. Muhammad Endi Julianto, and respected lecturers. And of course, our beloved participants. First of all, let us be grateful to the Almighty God for His blessing that allow us to gather here in good health and okay. Today's event as the Master of Ceremony. Ladies and gentlemen, today's seminar will begin with several agendas. First, singing of the Indonesian National Anthem. Opening remarks from the representative of study program and the Dean of Vocational School. Handing over the certificate and ceremonial signing. Continued with the main lecture session led by our moderator. Before we proceed, let us take a brief moment to pray according to our beliefs. Prayer begins. Thank you. Ladies and gentlemen, please rise. Let us sing our national anthem, Indonesia Raya. The committee in charge may launch the script. Thank you. You may return to your seats. Ladies and gentlemen, the welcoming remarks will be delivered by Dr. Hermawan Dwi Arianto on behalf of the Industrial Chemical Engineering Program. To Dr. Hermawan, please come to the podium. Thank you for the speech. Next, we will listen to the speech from the Dean of Vocational School. To Professor Budiono, please come to the podium. Thank you for the speech. Ladies and gentlemen, we will now proceed to the next agenda, which is presentation of certificate and of appreciation to our honorable guest lecturers and ceremonial signing of. Ladies and gentlemen, we will now proceed to the next agenda, which is presentation of a certificate of appreciation to our honorable guest lecturer and ceremonial signing of the implementation arrangement between Vocational School, Universitas Diponegoro, and Setsunan University, Japan. This certificate is a token to our deepest appreciation for his valuable contribution and insightful lecture on fundamental of food engineering in today's visiting professor program. We would like to invite the Dean of Vocational School, Universitas Diponegoro, Professor Dr. Budiono, to kindly come forward and present the certificate to Professor Hidefumi Yoshii. Thank you, Professor Yoshii, and thank you, Professor Budiono. May today's knowledge sharing become meaningful and inspire further academic collaboration between Universitas Diponegoro and Setsunan University. Now, let us have a short documentation session. For all participants, please stand up. First, a formal pose. 1, 2, 3. Second, vocational spirit pose. 1, 2, 3. And finally, when I say vokasi, please respond with juara. Vokasi. Thank you for your enthusiasm. Ladies and gentlemen, you may now return to your seats. Ladies and gentlemen, we are now pleased to announce the Visiting Professor Lecture 2025 with the theme Fundamental of Food Engineering, presented by our distinguished guest, Professor Hidefumi Yoshii from Setsunan University, Japan. Ladies and gentlemen, today's session will be guided by Dr. Engineer Vita Paramita, an Associate Professor at the Vocational School, Universitas Diponegoro. She earned her bachelor's degree in chemical engineering from Universitas Diponegoro and continued her master and doctoral studies in biotechnology and food engineering at Tatari University, Japan. With research interest in food engineering, nano-emulsification, spray drying, edible films, and functional food encapsulation, she has actively contributed to national and international research projects, published widely in reputable Scopus Index journals, and presented at global conferences. Beyond her academic achievements, she is also engaged in community service projects related to sustainable development and green technology application. With her outstanding expertise and experience, we are honored to welcome Dr. Engineer Vita Paramita as today's moderator. With that, time and place are yours. Ladies and gentlemen, please pay attention because the Visiting Professor 2025 program is about to start. We kindly seek your cooperation to make today's seminar run smoothly. Kindly switch your mobile phones to silent mode to avoid interruptions. Thank you for your kind cooperation and attention. Assalamualaikum warahmatullahi wabarakatuh. Salam, Om Swastiastu, Namo Buddhaya, Salam Kebajikan, and Salam Sejahtera to all of us. Welcome to the Honorable Professor Hidefumi Yoshii from Setsunan University, Japan, our distinguished guest lecturer. Dean of Vocational School, Universitas Diponegoro, Professor Budiono. Vice Dean of Vocational School, Dr. Ida Hayu Dwimawanti and Dr. Engineer Vita Paramita. Head of Study Program, Dr. Muhammad Andi Julianto, and respected lecturers. And of course, our beloved participants. First of all, let us be grateful to the Almighty God for His blessing that allow us to gather here in good health for the Visiting Professor 2025 program. Allow me to introduce myself. I'm Ines Takia from Industrial Chemical Engineering, Vocational School, Diponegoro University, and I will guide today's event as the Master of Ceremony. Ladies and gentlemen, today's seminar will begin with several agendas. Start with singing of the Indonesian National Anthem, opening remarks from the representative of study program and the Dean of Vocational School, handing over the certificate and ceremonial signing. Continued with the main lecture session led by our moderator. Before we proceed, let us take a brief moment to pray according to our beliefs. Prayer begins. Thank you. Ladies and gentlemen, please rise. Let us sing our national anthem, Indonesia Raya. The committee in charge may launch the screen. your seats. Ladies and gentlemen, the welcoming remarks will be delivered by Dr. Hermawan Dwi Arianto on behalf of the Industrial Chemical Engineering Program. To Dr. Hermawan, please come to the podium.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. The Honorable Dean of Vocational School, Professor Budiono, the Vice Dean Vocational School, Dr. Engineering Vita Paramita, and respected lecturer and also staff, and also all the participants today who is coming and join the meeting. So thank you very much for coming today. Firstly, on behalf of the study program, we would like to thank our distinguished lecturer, Professor Hidefumi Yoshii from Setsunan University. We are very happy to having you here, Sensei. So in this occasion, Professor Hidefumi Yoshii will conduct the several activities in our faculty and our department, such as the lecturing in today and then the day after tomorrow and in Friday. And also Professor Yoshii will guide us during the laboratory workshop in our TEFA teaching factory. Then Prof. Yoshii also teach us how to prepare the manuscript for publication international in the reputable journal. So I think this is a good opportunity to all students, especially for the final stage student. You can discuss with Professor Yoshii. So we already prepare some discussion session with him. So you can join the program. We also would like to thank you to our dean, Professor Budiono, who always support us as the Department of Chemical Engineering Technology during the world-class university program. So adjunct professor is one of the strategy to increase our international collaboration. So in this year, we have the two main programs during the world-class university program. First is adjunct professor, and also the international research networking. And also one of guests from Japan also will come to our faculty next week, so we can discuss later about that program. So once again, thank you very much, and hope all the students can enjoy during the lecture and ask many questions to Professor Yoshii. Thank you very much. Imakaramo sensei, hontoni arigatou gozaimasu. Imakara yoroshiku onegai shimasu. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Hermawan, for the speech. Next, we will listen to the speech from the Dean of Vocational School to Prof. Budiono. Please come to the podium.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, we can meet together, hopefully everything in healthy condition. The Honorable Professor Hidefumi Yoshii, thank you very much, arigato, for supporting us, because always support our vocational school for increasing vocational education system in vocational school Diponegoro University. Vice Dean Bu Vita, Head of Study Program, especially Secretary of Study Program, Mas Hermawan, Faculty Member, Mbak Anggun, Mbak Heni, Mbak Febi, dan yang sangat saya banggakan adik-adik mahasiswa. Jadi adik-adik mahasiswa harus tahu ya bahwa tahun 2026 sekolah vokasi itu masuk kepada fase sekolah vokasi kelas dunia, world class vocational school. Ya. Untuk itu maka salah satu kata kuncinya adalah international exposure. Jadi paparan dunia internasional ya adik-adik ya. Mahasiswa sekolah vokasi harus memiliki paparan dengan dunia internasional yang cukup tinggi, intensitas tinggi. Itu dalam rangka menuju kepada menyiapkan world class vocational school. Maka adik-adik ada summer course, ada student and staff exchange, ada visiting professor, ada adjunct professor, kemudian dan lain-lain. Itu harapannya betul-betul adik-adik sudah terekspos dengan dunia internasional dengan baik. Juga di dalamnya adalah magang minimal 1 tahun, 1 semester atau 1 tahun di industri ataupun juga sekaligus di luar negeri. Adik-adik, Bapak Ibu, ini saya baru saja juga pulang dari Jepang ya, 5 hari memantau bagaimana adik-adik kita, anak-anak kita yang sedang magang di Jepang. Ya, saat ini, detik ini, itu ada teman-teman Anda yang juga sedang magang di Jepang. Di sana magangnya 1 tahun, kemudian semuanya dengan bahasa Jepang, dengan gaji yang cukup tinggi. Ya mungkin kalau untuk adik-adik mahasiswa sangat tinggi. Kalau saya masih muda mungkin saya akan ikut juga. Jadi adik-adik teman-teman kita yang magang di Jepang itu gajinya antara 15 sampai 25 juta rupiah. Itu hasil wawancara. Minimal mereka kalau misalkan yang gajinya 15 juta, dia bisa cukup nyaman dengan hidup dengan 4 juta. Mas Hermawan cukup ya untuk mahasiswa S1 gitu ya. Mahasiswa S1 hidup dengan 4 juta di Jepang itu sudah sangat-sangat nyaman. Sehingga mereka yang gaji paling rendah itu bisa nabung minimal 11 juta per bulan. Maka tadi malam, kemarin saya tanya, Mbak, Mas, sekarang tabungannya ada berapa? Saya baru 35 juta gitu. 35 juta itu tinggi sekali adik-adik semua ya. Itu Bapak Ibu dosen aja tabungannya nggak sampai segitu gitu ya. Bapak Ibu mohon dukungan. Masalah paling utama adalah bahasa ya. Japanese language, masalah utama. Di Jepang banyak sekali lowongan pekerjaan, banyak banget gitu ya. Masalah utama tinggal bahasa. Jadi adik-adik tolong boleh sambil iseng daripada lain-lainnya itu sambil iseng belajar bahasa Jepang. Sekarang fasilitas sudah banyak sekali, banyak banget. Pakai AI itu belajar bahasa Jepang betapa mudahnya, belajar bahasa Inggris betapa mudahnya, manfaatkan itu. Ya, itu jangan sampai tertinggal. Sekarang ini Jepang ataupun Mandarin, itu dua ini yang sangat, itu kalau bahasa Inggris kan teman-teman sudah paham semua ya. Tapi setelah ini yang paling penting adalah Jepang dan Mandarin. Nah dalam konteks ini di Jepang luar biasa banyak, maka Jepang bisa salah satunya disiapkan. Itu jadi tolong adik-adik juga membantu menyiapkan masa depan masing-masing. Terkait dengan teknik kimia, adik-adik, apa sih kelebihannya Indonesia gitu ya? Apa sih kelebihannya Jepang? Kita harus paham semua ya. Kelebihan Jepang adalah teknologi, ilmu pengetahuan, science and technology, itu kelebihan Jepang. Apa kelebihan Indonesia? Kelebihan Indonesia adalah sangat kaya akan natural resources and human resources. Sangat kaya sumber daya alam dan sangat kaya sumber daya manusia. Itu adalah kelebihan Indonesia. Jepang, adik-adik perlu tahu, saat ini kalau adik-adik ketemu orang Jepang, mohon maaf, tiap ketemu 4 orang Jepang, itu minimal satu usianya sudah di atas 65 tahun. Boleh Anda cek secara umum ya. Di Jepang itu sudah decline growth ya. Pertumbuhannya sudah negatif. Itu. Sehingga mau tidak mau memang kemudian harus ada supply pasokan tenaga kerja dari Indonesia. Gitu. Maka adik-adik tinggal menyiapkan diri saja gitu ya. Sangat kaya akan sumber daya manusia, sangat kaya akan sumber daya alam. Adik-adik ingat bahwa Industrial Chemical Engineering Technology fokusnya akan bagaimana mengolah bahan baku, sumber daya alam menjadi bahan jadi. Bahan baku melimpah di Indonesia, teknologi melimpah di Jepang. Klop sekali kalau adik-adik mau menyiapkan ya. Maka Bapak Ibu dosen kalau kolaborasi dengan Jepang yang mudah sekali. Kita kaya akan sumber daya manusia, sumber daya alam, Jepang kaya akan teknologi, ketemu klop itu. Jadi itu adik-adik dari TKI tolong dimanfaatkan dengan sebaik-baiknya. Mungkin dalam kesempatan ini memang saya sengaja bahasa Indonesia biar fasih gitu ya, dan juga bisa ditangkap dengan baik. Saya ingin ngecek adik-adik yang hadir di ruangan ini siapa yang sudah pernah pergi ke Jepang. Sudah ada? Pertanyaan saya yang kedua, ini tolong, sudah ada belum? Ya dah, sebentar. Pertanyaan yang kedua, adik-adik ini tolong angkat tangan siapa yang sudah pernah ke luar negeri. Semuanya, tolong angkat tangan. Tidak apa-apa, nggak usah malu-malu, yang sudah pernah. Masuk hanya satu. Satu ya, siapa lagi? Yang lain? Ya, itu siapa yang sudah memiliki paspor? Ayo, 1, 2, 3, 4. Sudah punya paspor ya? 5, 6, 7, 8, 9. Ya. Jadi ini bagian tugas dari Bapak Ibu dosen, Bapak Ibu Kaprodi, Bu Wadah 2 gitu ya. Saya ingin adik-adik mahasiswa semuanya sudah memiliki paspor dalam rangka menuju sekolah vokasi kelas dunia. Itu minimal begitu ya. Kalau adik-adik ditanya, loh Anda memang siap ke luar negeri? Siap, buktinya apa? Saya sudah punya paspor gitu ya. Itu bukti sederhana sekali begitu. Jadi sekarang ini hidup sudah punya imigrasi yang di Muladidom itu, manfaatkan sebaik-baiknya, sangat murah, tepat waktu, kemudian tidak ada biaya lain-lain ya. Itu manfaatkan. Itu mahasiswa TRKI semuanya harus punya, nanti minimal bisa untuk piknik ke Singapura atau Malaysia dengan biaya sangat murah itu. Ya. Mungkin itu sepintas dari saya, mohon dimanfaatkan sebaik-baiknya, perkuat kompetensi, yakin percaya diri, kemampuan pasti oke, hard skill pasti oke, soft skill bisa dibina dengan sebaik-baiknya, kemudian insya Allah adik-adik semua bisa siap memasuki kepada pasar kerja. Yang terakhir Bapak Ibu adik-adik, kemarin sudah muncul peraturan Menteri nomor 39 tahun 2025, baru saja. Intinya adalah bahwa mengapa muncul peraturan tentang penjaminan mutu itu, intinya adalah di peraturan baru itu ingin memastikan bahwa sistem pendidikan sudah menjamin bahwa lulusan sudah siap masuk kepada pasar kerja global. Itu yang paling penting. Nanti Bapak Ibu bisa cek di bagian menimbang ya. Di peraturan itu bagian menimbang itu memperbaiki bla 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 supaya sistem pendidikan di Indonesia siap memasuki pasar kerja global. Itulah saat ini vokasi yang sedang dilakukan, maka adik-adik manfaatkan sebaik-baiknya. Bapak Ibu dosen mohon dukungannya. Ini yang duduk di depan tuh kelihatannya hampir semuanya sudah ke Jepang nih ya. Wajahnya udah wajah Jepang gitu. Demikian akhirnya finally Jang Professor Program and Implementation Agreement this morning by Bismillahirrahmanirrahim is officially open. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Next. Thank you, Professor Budiono, for the speech. Ladies and gentlemen, we will now proceed to the next agenda, which is presentation of a certificate of appreciation to our honorable guest lecturer and ceremonial signing of implementation arrangement between Vocational School Universitas Diponegoro and Setsunan University, Japan. This certificate is a token to our deepest appreciation for his valuable contribution and insightful lecture on fundamental of food engineering in today's visiting professor program. We would like to invite the Dean of Vocational School Universitas Diponegoro, Professor Budiono, to kindly come forward and present the certificate to Professor Hidefumi Yoshii. Thank you, Professor Yoshii, and thank you, Professor Budiono. May today's knowledge sharing become meaningful and inspire further academic collaboration between Universitas Diponegoro and Setsunan University. Now, let us have a short documentation session. For all participants, please stand up. First, a formal pose. 1, 2, 3. Second, vocational spirit pose. 1, 2, 3. Okay. And finally, when I say vokasi, please respond with juara. Vokasi? Thank you for your enthusiasm. Ladies and gentlemen, you may now return to your seats. Ladies and gentlemen, we are now pleased to announce the Visiting Professor Lecture 2025 with the theme Fundamental of Food Engineering, presented by our distinguished guest, Professor Hidefumi Yoshii from Setsunan University, Japan. Ladies and gentlemen, today's session will be guided by time and place are yours.
Assalamualaikum warahmatullahi wabarakatuh. Salam, Om Swastiastu, Namo Buddhaya, virtue greetings, good morning, Professor Hidefumi Yoshii, PhD from Setsunan University, our distinguished guest lecturer today, and also Mrs. Yoshii Okusama, dozo yoroshiku onegai shimasu. Thank you for our Dean of Vocational School Diponegoro University, which always support TRKI until now, and also the Vice Head of Study Program, Dr. Hermawan Dwi Arianto, and all respected lecturers, our beloved students, and also our proudly committee who's preparing today's Adjunct Professor event. And allow me to guide this remarkable lecture entitled Fundamentals of Food Engineering. But before starting, let's we knowing more to Professor Yoshii by sharing his CV. So please to the operator to show Professor CV. Professor Hidefumi Yoshii has actively engaged in the field of food science and engineering since 1983, and focusing the research and on the encapsulation of functional food compounds and flavors. He has received several prestigious awards in Japan and also worldwide, especially as outstanding mentorship and sustained excellence in drying research. So his contribution highly recognized through his publication and roles in reading reputable academic journal and organization. So let us warmly welcoming Professor Hidefumi Yoshii to share the lecture. The time is yours, Sensei. Yoroshiku onegai shimasu.
So thank you for joining the lecture. So I prepared the 90th slide, but almost 1 hour of a ceremony. So I'm happy to okay. But today I want to please have a slide. Yeah. Point. Can I have a pointer? Or so today I'd like to talk about the fundamental of the food engineering. But the first, Dean said, international communication and international work is very important. So today I have a no. So can I have a first slide and yeah, and so I have a 1 hour lecture. But you are happy. I'm very glad to have this kind of lecture. So I'd like to have many questions for the students. I very fun to see the extensive face of the students. So today I have 3 questions. So I touched this one. So please have an answer. So you have a very good seat. I have a first question. Oh, it's okay? Question. Yeah. So just Herman, this is the correct slide? Yeah, but so in the food engineering, we can see the many products. So the mayonnaise and gel and oil and some kind of the bombs, crushing and some kind of powder, yogurt, and margarine. So these products have some kind of the good effect obtained through processing, improve the taste. Oh. Which one is how to use it? Yeah, yeah. So, oh, so I came from the Osaka, and I also graduated the National Technical College, like the vocational Osaka. Yeah, yeah. So, and next slide, please. Oh, can I? Oh, so this is the three questions. So please prepare the answer. So why is coffee luwak coffee so delicious? So how can we artificially replicate the fermentation process that occurs inside the cavity, severe digestive system? So how do you think about it? Where is the Saboa? Saboa さんはどこですか？ダフはどこですか？ Yeah, please have answer. You answer.
Why is kopi luwak so delicious?
What's the difference? The conventional coffee and the coffee luwak coffee.
Oh, I think the taste is better in kopi luwak, better than the non-luwak coffee. So the taste is more delicious. Many people say that kopi luwak is even more delicious than the non-kopi luwak. As far as I know.
Thank you. So the coffee luwak coffee is have a many smell. Yeah, please sit down. And when we think about the smell and flavor, the word difference. Smell is only we can take the flavor, smell. But the flavor mean when we digest in the mouth of some kind of the food, and some kind of the flavor contain some kind of the effect from the texture. And in the mouth, not nose, include the whole, the flavor. So when we think about food engineering, so the meaning food engineering, we have to think about what difference, flavor and smell. So that when we make the product, recently product, with the nanotechnology, so that when we think about some kind of product, food product, recently we have to think about digestion system, stomach and intestine, and the absorption of the nutrient in intestine. So, second question is the concept of the boundary layer is extremely important in chemical engineering. So what is the boundary layer? So the almost 1 hour's lecture, so ceremony have 1 hour. So therefore I focus my lecture so that in the chemical engineering, boundary layer thinking is very important. Mass transfer, heat transfer, those transfers phenomena have a boundary layer. We can get the one parameter, mass transfer coefficient. Those simple model is very important in chemical engineering. And also in chemical engineering and food engineering, what's the difference? Chemical engineering, food engineering difference. The food engineering treat the multi-component system, multi-phase system. In chemical engineering, the phase is very simple. But the food engineering, very complex, we treat the complex system. Third question. So maybe after one of the lecture, I have a question. So especially for have a passport and Japanese, and you can go to the Japanese. So they have a, please prepare. Okay? You will. Okay? What is your favorite food and why? Please explain your answer using an engineering analogy that compare it to the human romantic relationship. Make sure to include the importance of the quantity in your explanation. So the engineering, chemical engineering, food engineering, important the quantity and also the quality. So please think about what's the difference between the cooking and food engineering process. Quantity is very so difference. In food engineering, we have to treat the large amount. In the cooking, we treat the small amount. So, therefore the quantity is very important. This quantity meaning the scale up. In food engineering, scale up is very important. So please prepare this answer. But please don't use the iPhone or mobile phone. So maybe in AI era, so the importance point, think about yourself. Not use the iPhone and the mobile phone, Android phone, or computer. So maybe the AI era, maybe the future, you cannot see the professor or lecturer. So only you can use the special lecture, can use the YouTube. So that when you want to see the good lecture, so please check the whole thing, food engineering. You can say, have many lectures. But when you see the YouTube don't have the question. So I'm very fun to have a student extension phase. So please prepare the answer. So thank you. And which one? Which place? Next slide, please. So in the food engineering, so when we think about some kind of the importance war, units and balance in chemical engineering also. So yeah. So do you know the unit of the force? Force. Newton. Oh, okay. Yeah. Yeah. I can. So, fundamental of the quantitatively dealing with the phenomena, dimensions and unit and balance. So I have only 1 hour's lecture. So I focus the dimension and unit. Yeah, thank you. Not. Next slide, please. Oh. Next is, this one. Next is this one. Next slide. This one. Oh, yeah. What? Oh, yeah. In the unit operation, we can see the many operations. The diffusional operation, mechanical operation, transportation operation, temperature and control option, others. So, and we can see the many unit operations. And then, first, oh, yeah. The one back slide and this. Can I see? Yeah. So first, please remember the partition coefficient. So partition coefficient, when a substance is distributed between two immiscible solvents, it represents the ratio of the concentration each solvent. So this is some kind of equilibrium parameter. And then next slide, the separation factor. Separation factor is an index showing effectiveness of separation of two components. So when we think about some kind of phenomena, we have to think about the equilibrium and the transfer. So the material transfer and equilibrium state, so how the substance move, transfer of the substance, what happens after time has passed equilibrium state is important. So when we think about the two phenomena, some kind of a transfer rate and the equilibrium. So in the chemical engineering, so we treat those operations. Now is I focus dimensions and unit. Please remember that dimension and unit is very important. So unit a mean of the quantity expressing the physical quantity. Basic unit, length, time, derived unit, the combined base unit, like the Newton. Oh, this one. Next. Yeah. Then yeah. Next. So about the unit, first think of the unit, and please remember the pressure, force, stress, energy, work, heat, power. So but basic unit, length, mass, time, electric current, thermodynamic temperature, and amount of substance, luminous intensity, and we can see the 7 unit. And next, so first, please remember the Newton's law, F equal ma. Force mean the mass times acceleration. Acceleration unit, mass unit is the kilogram, gram. Acceleration is a meter per square meter a second. So the pressure unit is Newton per square meter. So energy unit, Newton times meter, force times length. This means the joule, energy unit. Power unit, joule per sec. So please remember the force unit, Newton, Pascal, joule, watt. So this unit is very important. So for example, a unit of physical quantity, thermal conductivity unit is watt per meter Kelvin. So this unit meaning power times thickness per time area temperature difference. So also the unit is heat capacity, joule per kilogram Kelvin. So viscosity unit, Pascal sec. But the kinematic viscosity unit, meter square per second. So when we think about this equation, momentum flux equal minus mu du by dy. So when we think about this equation, mu's unit is a Pascal sec. So first, please remember Newton's law, F equal ma. Mass times acceleration. When remember this equation, we can get the Newton force unit. And when we have a force and bring some kind of length, Newton meter equals joule is energy. So those unit is very important. So this means we have to think about the dimension. So 1 kilogram, 2 kilogram, this is 1 kilo, for example, 1 kilogram, this is 3 kilogram. We can plus 1 kilogram to 3 kilogram. But we cannot add the kilogram mass plus length. We cannot. So when we treat some kind of the phenomena, every time we have to think about the unit. So when we think about energy unit, when we eat the hamburger, we can get this means that we can get about 400 kilocalories. This means 1,749 kilojoule. So joule is the work done when a force of 1 Newton moves an object 1 meter in the direction of the force. Also, calorie, the amount of heat required to raise the temperature of 1 gram of the water by 1 degree of Celsius at standard atmospheric pressure. So when we eat the food, also we have to think about this energy unit, energy. And then also the mass balance. So also, please remember the gas constant unit. Gas constant unit is joule per mole Kelvin. So in the chemical reaction, you can get the activation energy. Also, when we cook the potato, we can get the cooking rate of the potato. On that time, also, we can get the activation energy. So, R is the joule per mole Kelvin. So the activation energy unit is the joule per mole. So what mean the mole in the cooking of potatoes activation energy? Joule per mole. What's the meaning of that? Please think about it. So just skip that. Yeah. So in the food engineering, in chemical engineering, holds some kind of the water physical state in food. So in the food, we can see the many type of the water. Capillary water, physical substance water, hydrogen bonding water, chemical substance water. So in food system, so the absorption, so the gaseous water molecules inside of the water is there. So that we have to think about the mobility of the water. So engineering, please think about equilibrium state, transfer state. We think about the both state. So equilibrium state, for example, the solubility is the solubility of the gas in water. This is the equilibrium parameter. But the diffusion coefficient of the flavor, that is a transfer parameter. In the engineering, we can see the many parameters. So those is the transfer parameter or equilibrium parameter. And then also some kind of the water activity is A equal P by P0. P is the vapor pressure in food. P0 is the vapor pressure of the pure water. So this kind of ratio, this is not have a dimension. But A, water activity, also the humidity. Humidity also, relative humidity also don't have the unit. But we have to think about the pressures unit and humidity unit. So the equilibrium means the phase equilibrium, but in food we have many type of the phase. Solution, the water phase, solution, glass, melt, crystal. And then in the food, when we think about the food, lava state is very important. Lava means a very soft material, crystal very hard, glass is very hard. Between the lava and glass, we can see there's some kind of parameter, glass transition temperature. So in the food engineering, in chemical engineering, we can see the many parameters. So many parameters from the simple model, like the boundary layer. So also, we have think about the phase, water phase, so liquid phase, solid phase, and so in the some kind of solution system, we can see the very simple three phase. But in food, please think about the bread. Bread have a solid. Inside have a many cavity, gas. And then also the many components. So the very complex structure, size. So in the engineering, we have to think about the history. When we make the coffee, instant coffee, we prepare a cup of coffee and the coffee powder, milk, hot water. So initially, someone coffee powder put in the coffee pot, and then pour the hot water, and then starting. But another one, initially pour the hot water and put in the coffee powder to the coffee hot water, and then mixing. In the engineering, we have to think about the process. When we make the coffee, instant coffee, initially the put in the cup powder, or initially pour the hot water. The solution rate is different. So in AI era, so the computer have many suggestions, but they don't think about the many process. On that time, AI case, we have some kind of questions, many questions. First, we prepared the powder, coffee powder, liquor powder. So what's the difference of the liquor powder and instant coffee powder? Difference of we can see the many difference. Liquor can select the perfectly ripening beans. They picked up the very good beans and eat. They select the good bean, and then at intestine, some kind of the fermentation. So in the fermentation of the solid, so we have to think of the solid. Solid, what's the solid fermentation? So think about the structure, shape, and size. When we think about make the instant coffee, so the coffee powder's size. So when we put in the powder to the hot water, initially hot coffee powder floated on the hot water, and then go down to the coffee powder to the inside of the water, hot water. So those phenomena is important. So then engineering, so those process, we have to think about the solidation rate. So the one is a very good example of the solidation rate is the response of the stirring or solidation. On that time, we can get the parameter, solidation rate. So, can I use this is good, not original. かける? Oh, yeah. Okay. Yeah, when we think about the solution of the coffee powder in hot water, we can get some kind of this kind of time, concentration of the coffee. So every time, please think about the unit or oh. Hmm? Oh, yeah. Oh. So, dimensionless unit or conventional unit, and this have a time and sec, and then we can get this kind of the equilibrium. This kind of curve is the first order relation, some kind of step response. So when we think about some kind of the phenomena, for example, the degradation of the cosmetic compound, this kind of you can see for example, the vitamin C content degradation in the cosmetic, or this is not months and week, but the sec or day and this kind of this is a fast order degradation. But when we think about this kind of oh, yeah. Oh, yeah. This is a first order reaction rate constant. This unit is this unit. So this is the one parameter. Also the solubilization rate. We can get some equation, solubilization rate. K, some kind of the unit is so food engineering and chemical engineering, we can get the many parameters. So those just skip. Yeah. For example, this is the absorption, water absorption of the cornstarch. We can get this kind of the curve. But the meaning of the water activity, the mean the humidity, environment humidity. But the water activity don't have the unit. But pressure have a unit. Pressure means the water vapor pressure means the mass of the water in the gas. So when you can get some kind of the many parameters in the engineering. So this is the rate parameter. So the C star, this is the equilibrium parameter, solubility. Some kind of Henry's constant. This kind of the parameter of a unit. So that when you think about some kind of phenomena, every time, please think about the unit. Next, in the engineering, when we think about the solubilization of the coffee powder, small coffee powder, solubilization rate is very rapid because the surface area is very larger than this one. So the surface area is being the volume of this powder, and the surface area of this is surface area. So this means that we think about the shape and size. When we make the milled kopi rokua is very expensive. So we make the small amount of the coffee powder. So coffee powders, I want to clean up this whole structure. Thank you. Coffee powder have some kind of the shape, but when we think about some kind of the very smoothly spheres, but how to think about the size? So maybe we can think about the E1 and D2 and the so, and then get some kind of the one parameter and some kind of the average, and also the spheres DAP, and so the size, shape, and this also the amount, engineering. We think about the amount. So in the cooking, I like the nasi goreng. So but some company, food company, want to control the freeze-dried nasi goreng. So how to cook the rice? Some machine have a rotating, this is the rice, and rotating machine cooking. Some companies have a big fry pan, and then starting of some kind of scope. So which one is better? So those, when we think about make the large amount of the nasi goreng, so how to control the temperature, and how to control the heat transfer, how to control the flavor content, how to control the water content. So this every time in food engineering, think about the amount. Also in the food engineering, in the many components, nasi goreng and the rice, gelatinization of the rice, but the absorption of the flavor to the rice, gelatinized rice, And then in engineering, oh, please clean up. Yeah. In food engineering, so the source is natural. So sometimes the cooking process, rice, initial rice, and the materials every year change. Some kind of water content, rainy season, and after rainy season, and after some kind of weather's conditions, rice condition is different. Water content is different. And also the some kind of starch structure difference. And then get the cooking process, get some kind of the product. And then we have to think of the storage, and then some kind of the process cooking. Small amount of cooking and eat. Recently trend, we have to think about the source. And then we have to think of a storage condition. So some kind of product contain the vitamin C in the product. During the storage term, vitamin C degraded. So there's some kind of the, for example, in the vitamin C content in the process, heating process, starting process, also but think about the process, this process. And then after make the product, we have to think about them. So the storage terms, and then some kind of the cooking and treatment, and then absorption of the vitamin C at the stomach. Recently trained food engineer think about this process, absorption. So therefore the food engineer, chemical engineer, we have to learn the metabolism of the food in intestine, absorption system. And then this is the water absorption starch structure. We remain the many slides. So after lecture, I can send the Helmman. So the one slide have one question. So please think about the questions after lecture. So I stayed almost 2 weeks. I can make them many questions for you. I'm very fun to have questions. So in the engineering, in food engineering, so in chemical engineering, process is very simple, and think about this kind of this term. But in food, natural meaning the complex and the multi-component. Multi-component. And then in the food engineering, after make the product, we think about the storage. So therefore we have to think about the package. So for example, ladies, this trees may also like the cosmetic, keep the humidity on the skin. But the cosmetic product is very expensive. Therefore, use the small amount. Keep the long range, but the oxidative active compound, like such as vitamin C, degrade it. May the company's shelf life think about that 3 months, but someone 1 year. Someone is the 2 year, 5 year. So therefore, please think of storage time. And after you take out the cup, so also we have to think about on the skin, some kind of reduction compound amount. Therefore, in the food engineering and also the cosmetic engineering case, we have to think about the many process during the process, during the storage, during the eating. So on that time, so simple engineering case, we have some kind of parameter, degradation parameter, K1 and K2 and K3 and absorption rate, and so in the engineering, please have a simple, please make the simple model, simple thinking, and get the parameter. But these parameters, think the unit, first order, degradation rate constant. So please think about the remaining 15 minutes. It's okay? Students like the long lecture, so they like my questions. So, therefore, when we think about this kind of as a water absorption data, we can get the 3 Guggenheim, some kind of absorption model, and think about some kind of model. And then also the water activity mean so the y-axis, the reaction rate, and then x-axis, the water activity. When we think about the effect of the water activity to food, so some kind of this food stability map is very important. So this figure make the famous professor in United States. Their love have not the many instruments with balance, desiccator. Initially the desiccator and the balance, with balance. And then some kind of they check the color. So the idea, we don't need the good instruments. Some idea is very important. So and then make the figure. So iPhone could not, recently can make the figures. So when I have some kind of questions, so some kind of water activity of some kind of food, so what kind of the data, please show the data. And the next question, they have a questions. Please show the diagram of the water equilibrium, absorption equilibrium figures. But every time we have questions. But in human case, you can make the figure. This kind of the writing figure is important. When you have some kind of special idea, you can write the figure. So, pencil, not computer's pencil, old pencil and notebook is important. When you have some kind of lecture, Herman make some kind of figure, slide, someone take one photo. They someone distribute the slide. You cannot use a pencil. With that pencil, you get that one slide or many slides. But on that time, you cannot get the idea. So my suggestion, please use the pencil. But this kind of the board case, spontaneously she can clean up. But the notebook case, you can see some kind of every time you can see this kind of figure and the drawing. So in engineering, so that you can get the parameter, equilibrium parameter, rate transfer parameter. We have two kinds of the parameter. Parameter have so can I skip the many slide and then show. Oh yeah. Yeah. So, for example, and the heat transfer case. So for example, heat transfer, we can. This is the bulb and the heat transfer to this bulb. On that time, we have to think about some kind of heat transfer. Also, we can see some kind of electric flows model, Ohm's law. So we can make the simple model of some kind of liquid flow and electric flow, and So every time we think about a simple model, we have to think about simple model. Yeah. Oh, this is the next slide. Yeah. Next slide, please. Yeah. So the heat transfer case, so the, oh, yeah. This is a heat transfer, and then we can make some kind of model. The distance R1, R2, R3, and then we can get the heat transfer model. Also, we can make the electric flow model. So therefore the engineering case clean up the every time we think about the simple model, and then get some kind of parameter, equilibrium parameter, and the transfer parameter. Transfer parameters case, diffusion coefficient unit is this one. Also, this diffusion case, flux, in this fixed rho case, this is a flux, some kind of flavor flux and mass flux. When we think about the transfer model case, diffusion coefficient unit, this one. And then also, the flux, heat flux, the mass flux, and mean some kind of parameter times driving force. So oh, yeah, just flux. Can I see the flux? Yeah. So maybe for example, reaction rate and constant is some kind of K is this parameter. Diffusion coefficient is also the parameter. In this diffusion coefficient, yeah. Oh, yeah. Think about the boundary layer. Boundary layer is the move of the molecule is only the diffusion, not the real flow. And then think the D is the diffusion coefficient. And then mass transfer coefficient in the boundary. D is the diffusion coefficient. The thickness of the boundary layers, this is the length. So every time this is a very simple model. So that we can get some kind of the meaning of it. Please think about the meaning of the parameter. Transfer coefficient, unit the meter per sec. So when you think about some kind of model, what is the parameter? What is the very simple model? And then after, please think about the dimensionless number. Sharp number, Reynolds number, and Schmidt number. Those parameters have some kind of meaning. So please delete the whole, yeah. Oh, yeah. So, unit, first. Unit is very important. First, please think about the Newton law. Oh, oh yeah. This meaning Newton. The another Pascal, Joule, and Watt. Please remember these units, and then also the dimensions. And then in some kind of process, chemical process, photonic process, have two equilibrium and transfer. You can get some kind of parameter. And then think about the simple model. So the food is a very complex system. But you have to think about the food process on that time. So please make the simple model. And then when you make the simple model, you need some kind of this kind of the dimensionless number. Reynolds, Sharp number, and Schmidt number, and just can I next slide, please? Yeah, next. Yeah. So when we think about some kind of heat and mass and momentum transfer, so these transfer keys, flux, flux equals some kind of parameter times delta C, delta T, and some kind of momentum and energy and A dash and so driving force, some kind of parameter, diffusion coefficient, viscosity, and the heat transfer. So those thinking in the very simple model. Momentum case, you can get the viscosity. And also the heat flux case, thermal conductivity, and mass case, diffusion coefficient. Those flux coefficient parameter times gradient. This is a transfer case. Oh, yeah. Oh, yeah. And then heat flux case, thermal diffusivity is square meter plus kinematic viscosity, square meter, square meter. So that when we think about that, think about you need some kind of rate reaction constant. So the parameter. So and then think about the dimensionless number. And then skip the, so modeling, simplify, predict complex phenomena. Simplify is very important. So how to make the artificial copy liquid surface, how to simulate the digestion system with several kinds of the enzyme in intestine of copy liquid. So flavors formation, glucose degradation, and some kind of that. So every time, please think about that. For example, auto-oxidation polyunsaturated fatty acid ester case, oil, frying, oxidation in vivo. So we can think about this very simple model, the oxidation case. Yeah. So the reaction mechanism, initiation, propagation, termination, and then make some kind of the can I say next slide? Yeah, this kind of the auto-reactive catalytic reaction model and make some kind of equation. Recently, you don't need the advanced mathematical technique. How to write the degradation of the acid, oils compound. Please show the equation. So therefore, please get one parameter. So when we want to write some kind of papers, recently we asked the AI system. We can get some kind of very good idea, simple model. But finally, we need the original data. Who take the original data? So the important point, original data is very, very important. Maybe the many students want to do some kind of this kind of work. Well, you don't need that. This can only the speaking. You can get the equation. You can get the paper and the report. So the Herman said, please submit the report about some kind of diffusion model. Very easy to make report. So the question powder and which is a sugar salt. So you have to touch what is the sugar, what is the salt. So this kind of thinking recently is easy, not easy, but you can using the computer. But you have to get some kind of feeling from the material. And then original data is important. Yeah. This is some kind of model, and next. Oh yeah, get some kind of food engineering. We can make the model, and then next, yeah, we can get some kind of degradation kinetics, and next. Oh, some kind of parameter and yeah, next. And please show the final slide. Next. Yeah. Oh, yeah, this one. So the key concept in the food engineering, so unit is very important. So please remember Newton's law, F equal ma. Newton, Pascal, Joule, watt. What is the Joule? What is the energy unit? So and the balance. And then empirical formula are acceptable. So in the engineering, food engineering, chemical engineering, original data is very important. So please don't work at some kind of the clean room. Please have how to say that, Nagagutsu? Eh? Yeah. Please take the house kaki. Yeah. And then the hand make the very dark. So that in my student age, when we can get the Reynolds number, we use the buckets. But you don't need, recently, you don't need some kind of the computer experiment. Because the university don't have the money. Therefore, they don't use the water and buckets and, but the buckets, so the water amount, flow rate, so therefore the important point in the engineering, house kaki is important. Original data is important. AI cannot make the original data. So therefore but you can use the AI and computer, Excel, PowerPoint, and the many softwares. But also, please use the pencil. I don't like this kind of the computer pencil one, but very easy to clean up. And yeah, I remember. And then, so initially, unit, please remember the Newton's law, F equal ma, Newton's dimension, kilogram times acceleration, meter square per sec. So that this is the Newton's unit. So, and then please think about the simple model. You can get the parameter, equilibrium parameter, transfer parameter, two types of the parameter. And then every time you think about the simple model. And then finally, and you have to get the original data. So when you have a question, so, but he has to think about the third questions. So, yeah, favorite food. Yeah.
So My name is Arizaki Shaputra. I'm from TRKIB 24. Today I'm gonna answer the question about favorite food. My favorite food is fried chicken. I think in terms of chemical engineering is about food engineering is when you marinate the chicken. It's about mass transfer. It's like process you transferring. You trying to make the spice go into the chicken. Then you need to. Yeah, fried chicken. Fried chicken. Yeah. 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 So in the food engineering term, I think first, if you want to make a chicken, you need to marinate it first. Yeah. So in food engineering, I think it's term for mass transfer. What is mass transfer? In chicken term and when you try when you try to marinate chicken, you want the spice to come to go inside the chicken, so the chicken is going to be flavorful. So next, after you marinate the chicken, you want to coat it in flour. I think it's process for you make a boundary layer for in the chicken system. Then you want to deep fry the chicken, and I think in engineering analogy, it's about heat transfer. That's all. Yeah. 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 Yes. Oh, okay. I think. So I think the heat transfer is like in human romantic relationship is like when you meet someone, then you feel something inside your heart that uh, you 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 want to translate, you want to talk to her, but yeah, it's make you feel yeah, the nervous, dizzy. So I think it's like love. You want to transfer it to the to your crush like that.
So the heat transfer driving force is the temperature difference. What is the driving force of the love? What is the driving force?
Oh, driving force. What's driving
Yeah,
force?
heat transfer is the Fourier law. It's the driving force. Temperature difference.
Yeah.
Heat transfer. So the attack of the lava, what is the driving force in your case?
Yeah, tadi the driving temperature. Apa? Kan ini perbedaan suhu.
So every time, please think about the some kind of analogy. An engineer,
The
please think
distance,
about
bro.
the point. So that you feel ready of if the have many money. In this case, also the driving force.
Yeah.
Money
Thank you very much for Yoshii Sensei. We usually call I and Pak Hermawan for the insightful and this inspiring presentation. And I think it is very interesting. And Sensei still have one question. Let we think together and give the answer to the Sensei before he come back to Japan during his stay in Semarang. And Sensei, I think because of the time, so we have to close this session. Once again, give Sensei a huge applause. Mo ichido, domo arigatou gozaimashita. Yoroshiku onegaishimasu. Sama-sama. Yeah. Thank you, and we are closing this event. And I return the event to the MC. Wassalamualaikum warahmatullahi wabarakatuh.
Okay. Thank you to Professor Hidefumi Yoshii for the valuable knowledge, and also to our moderator, Dr. Engineer Vita Paramita. Before we end today's session, I'd like to ask, how was the lecture today? Is it fun? Of course. I believe many of you find it insightful and inspiring. Ladies and gentlemen, to conclude today's lecture, we have learned that food engineering provides the fundamental principle of mass and energy balance, heat and mass transfer, and fluid flow, which are essential to design and optimize food process. Professor Yoshii has also emphasized how these core concepts are applied in real industrial practice, ensuring food safety, quality, and efficiency. Ladies and gentlemen, lastly, we remind you to join us for upcoming session and on day 2 and day 3, where we will continue to explore further developments and insight into this important field. We look forward to welcoming you again. And this concludes our session today. On behalf of the committee, thank you for your kind attention. See you again at our next visiting professor lectures. Wassalamualaikum warahmatullahi wabarakatuh.